Some of those things involve where the zeros live. Some of them involve where asymptotes live. And then once we find those asymptotes, they're going to impact our domain and our range. So we're going to talk about domain and range as well. A graph may cross an asymptote, but it also may not cross an asymptote. So a graph may or may not cross an asymptote. So it can, believe it or not. Most of the time I tell people to think about asymptotes kind of like an invisible dog fence. It kind of like holds everything in. So when I think about like my aunt who lived out in the country and had a couple dogs, she had a couple labs who were super excited. She had an invisible fence in her yard because they lived way out in the country and had lots of acreage. And so the dogs would know exactly where the fence line was, right? So if they saw somebody, they'd be like, like, pet me please. But they would know where the fence line was and they'd stop. So I think of the asymptote kind of like the invisible dog fence. It's kind of like our barrier most of the time. However, there are times that we can cross that barrier. Not a vertical one, but you can cross horizontal asymptotes at times. Not always. It doesn't happen a lot. It does happen though. Okay, so we're going to see some of those. Maybe not today, but they do exist. I can't remember if I've got an example of one or not. Okay, let's talk about how to find asymptotes. So there are two different types that we're going to deal with. There actually is a third one that we'll deal with later in the year. It's called a slant asymptote. So it would be an asymptote that has slope to it. So we're going to talk about just vertical and just horizontal asymptotes right now. Okay, so just those two. Vertical asymptotes are the lines x equals a, where a is a zero of the denominator. Do we want the denominator to be zero? No good. So your vertical asymptotes happen when you have a fraction where the denominator would be zero. The horizontal asymptotes break into a list of 3 rules. So I'm going to give you those 3 rules, and I also find that it's helpful to give an example of each one, so I'm going to do that as well. So if the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is at 0, meaning the horizontal asymptote is y equals 0. So let me show you an example of what that could look like. So if you have a numerator where the degree is smaller, it could look like this. There are obviously infinitely many examples out there in the world. Here's one of them. Do you see how the degree of my numerator is smaller than the denominator? Yeah. So if the degree of the numerator is smaller than the denominator, I have an asymptote at 0. Okay? Let's look at the next option. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote, oh wait, hold on. Yes, no, I do want that there. Then the horizontal asymptote is the fraction formed by the leading coefficients. Let me show you what I mean by that. So if the degrees are the same, we could have something like 3x squared plus 7x plus 2 all over 5x squared minus 4. Again, I'm just making up random numbers. Do you see how my degrees are the same? Would you say the degree of the numerator is 2? Is the degree of the denominator also 2? Okay. So if the degrees are the same, then your horizontal asymptote is the ratio of the leading coefficients. I have a leading coefficient in the numerator of 3 and in the denominator of 5. So my horizontal asymptote would live at 3/5. So if I look at the horizontal line at 3/5, that's where my asymptote lives. If the degree of the numerator is larger than, sorry, I was like, that doesn't form a sentence, larger than the degree of the denominator, then there is no horizontal asymptote. And by the way, I'm okay if you abbreviate horizontal asymptote, HA. Make it H.A. Makes my life easier. So what would that look like? This would be when we have the numerator with a larger degree than the denominator. So maybe something like that. Again, there are infinitely many examples out in the world. I'm just making up stuff that it could be. So vertical asymptotes are when the denominator equals 0. Horizontal asymptotes, we have to figure out which situation we fit into and find it from there. Okay? So let's look at our first example. So what could the homework questions look like? I could give you a lovely rational function, like we have here, and I could say, find the vertical asymptotes. So how are we going to do that? When do I have vertical asymptotes? What has to be 0 for me to get a vertical asymptote? The denominator has to be 0. So I don't even care about the numerator right now. I truly only care about the denominator. So I'm looking at 9x squared minus 9x plus 2. And my question to myself is, when would that equal 0? Because that's going to tell me where my asymptotes live that are vertical. Now, you can solve this by any means that you would like to solve it. You can factor and solve. You can use quadratic formula. You could graph. You could complete the square. There are so many options. This one actually does factor. So let's factor this one. Let's see. We need 3x and 3x to get back our 9x squared. What else would I need? You can tell me what goes in the second spot of both. So I gave you the first. Minus 2 and minus 1. And remember, commutative property says, doesn't matter what order we multiply in. So you could have the minus 1 first and the minus 2 second. Let's double check, make sure we agree. 3x times 3x, yep, 9x squared. Negative 6 and negative 3 more, yep, negative 9. Negative 1 times negative 2, yep, it's 2. So we can always double check. So I want to know when each of these would be 0. So maybe you can see it. Right? Like maybe you can just pick it out, or if you can't, remember you can always just set it up and set it truly like when would it be 0. So I'd add over my 2, and then I divide by 3. So x equals 2/3 is one of my horizontal asymptotes. Now, when you write your asymptotes, it is an equation of a line. So you have to have it in this form. If you just write 2/3, it's not correct. I need to know that it's the equation x equals 2/3. So it has to be written like that. Okay, let's find the other one. Again, maybe you can just think about pulling it out. If this were 1/3, that would make this 1, and 1 minus 1 is 0. So 1/3 is my other asymptote. Watch you. Oh, you're opening your water bottle. Bless you as you open your water bottle. Thought it was a sneeze. Anyway. Okay, horizontal asymptote. Let's think through our 3 options. Is the degree of the numerator bigger? Nope. Is the degree of the numerator smaller? No. Are the degrees the same? Yes. So to find my horizontal asymptote, it's going to be in the form y equals, again, yes, you need the equation. So don't just give me a number. It has to be y equals because it has to be a horizontal line. Y equals, and we take the ratio of the leading coefficients. What's my leading coefficient in the top? 1, and in the denominator, 9. So y equals 1/9. So if I went to graph this equation, I should see that I have asymptotes at 2/3 and also at 1/3, and then I should see that I have an asymptote asymptote at 1/9. It may or may not touch or cross that, but it definitely won't touch or cross these. So you could graph them and kind of double check. Did I lose anybody? We're okay? Okay, I hear Patty. I just want to make sure we're good. You guys good too? Okay. Alright, I think I've got another one of those next. So good news, flip the page, we're going to do another one. So if you were like, yeah, I need to see that one more time. Good news, you will, on the next page. So flip, we've actually got 2 more of those. And then we're going to practice graphing, and then we're done for today. Alright, so these say, they're actually the same because it's B and C, so we're going to do a continuation. So we want to find vertical and horizontal asymptotes still. So we're going to continue on that same path. So let's find vertical asymptotes first for this one. So I'm going to say VA is my abbreviation. Vertical asymptote. What would my only vertical asymptote be for part B? 1. And again, it has to be in the form x equals because it is a vertical line. Remember, typically when we graph those in as a dotted line. Okay, horizontal asymptotes. Let's think through our list of rules. Is the degree of the numerator smaller than the denominator? No. Is the degree of the numerator bigger than the denominator? Yes. So what does that mean about my horizontal asymptote? It's at what? Anything? No, it doesn't exist. We don't have one. It's just none. I started to write y equals, and I'm like, that's not even helpful, because it's a none. All right, part C. Are we going to have some vertical asymptotes? Yes, no? Yes. Okay, let's figure out when the denominator would be 0. So vertical asymptotes, here we go. We've got x squared plus 3x minus 4. Again, you have so many options for how you could solve this to figure out when it's 0, but if it's factorable, I'm going to choose that every time because it's fastest. We know x times x is x squared. What multiplies to give me negative 4 but adds to 3? Minus 1 and plus 4. And again, you can have those parentheses flipped. It's to the commutative property. We can say, you know, it doesn't matter the order we multiply in. What are my 2 vertical asymptotes? X equals 1 and negative 4. Now, I don't care if you write it like this, where you have the comma in between, but again, you do need the x equals. If you don't have the x equals, I'm going to mark you down. All right. Horizontal asymptote. Is the degree of the numerator smaller than the denominator? Yes, there isn't even a thing in the numerator, right? We don't even have a variable up there. So my horizontal asymptote is at y equals 0. So we kind of spanned all of our different situations that could happen for the horizontal asymptote. All right. Let's see. One other thing I want to talk to you about that's not on this sheet, but I'd like to briefly mention it. Okay, give me like a little spot over here, little space where you can write something. Let's say that we have, let's go with x minus 3 over x squared minus 9. Okay, so this is a little note off to the side, and this is where we have a hole in our graph, is what we're going to talk about. So if I have x minus 3 in the top, what would I get if I factored the denominator? X plus 3, x minus 3. Do you see how I have a match of my parentheses? So this tells me that I have a hole in my graph at positive 3. So the value that would make these parentheses 0, the matching parentheses in the numerator and denominator, that value is where the hole lives in my graph. So what does a hole look like? If you graph, you can't see the hole on your calculator, but it will give you an error message. So let me show you really quick what this graph would look like. Let's see, parentheses. Remember, if you're plugging in a fraction, you need parentheses around the numerator, and then you need division, and then you'll have parentheses also around the denominator because it needs to be all together. Okay, so here comes the graph. Does it look like there's a hole somewhere? Okay, if I go to my table, I'm going to get a couple of error messages though. I have an error message at -3 because that would make this denominator 0, right? I have a vertical asymptote that lives there. Do you see how I have another error message at +3? Let's look at our graph again. Does it look like I have a missing spot at 3? It doesn't, does it? So remember that your calculator only has so many pixels. It's not a high-def TV, right? Like you've got the T's that are like curved and they're 5D and they're all the crazy wild things. Your calculator is not that. So you have to be careful. If I was graphing this and I had a hole at 3, there would be an open circle there. Kind of like when we were graphing the piecewise functions, I would have an open circle where the hole is. So just something to be careful of, just an extra little piece of information. Okay, let's move down here. We're only going to do one of them. Let's do part A. I don't think we need to graph 2. I think graphing 1 will be fine. Alright, let's think about horizontal asymptotes first. Horizontal asymptote. The degree of my numerator is smaller. What does that mean? Y = 0 is my horizontal asymptote. So in some way, shape, or form, my graph's going to kind of hug at y = 0. Again, it can still touch or cross it, but for the most part, we should see the graph kind of heading toward it as opposed to crossing it. Alright, denominator. Let's think about where our vertical asymptotes live. 2 sets of parentheses. We want to know when our denominator equals 0. So I'm going to draw these in before I do anything else, all the asymptotes in. X times x is x squared. What multiplies to -6 that adds or subtracts to -5? Careful. Yeah, -6 and +1. Easy to be tricked into 2 and 3 though, right? Like maybe that would work. Not here. So -6 plus 1 is -5, -6 times 1 is -6. So I have an asymptote at 6 and at -1. So I'm going to draw in all my asymptotes first, and then I'm going to draw in my graph with the help of my calculator. Okay, y = 0. I have an asymptote that lives right here. I have another asymptote that lives at +6. These lines did not copy well. 1, 2, 3, 4, 5, 6. So I'm just graphing my asymptotes right now. They're kind of my barriers, remember? Or boundary lines. And then I need one at -1. Alright, so now I'm ready to actually put my graph in there. I've got my boundaries set up. I'm ready to actually graph. Go to your calculator. If you didn't practice with me before, now is your time to practice. There's only one thing in the top, so I don't need parentheses. Although if you want to stay consistent, you can still put the numerator in a parenthesis house. That's not going to hurt anybody. The denominator has to go in a parenthesis house, though, because all these things belong together in the denominator. So x squared minus 5x minus 6. So that whole thing is in my denominator. And then I'm going to hit graph. Ooh, what a cool graph. We've got 3 different parts. Usually don't get so many parts. Okay, let's start with the part on the left. So we've got kind of this L shape, but it's reflected, right? So let's figure out some points on that part of our graph. So if I start to graph it, let's see. At -2, I'm at +0.75. So -1, -2, I'm at +0.75. And then do you see how these numbers get smaller and smaller and closer to 0, and they're just going to hug the y-axis? Okay? So this is going to hug right here. It's not going to touch or cross, it's just going to hug. And then this goes up and hugs the other asymptote. So typically, when we're working with asymptotes, our grafts kind of get real close to them, but again, they don't touch or cross. Okay, let's look at this middle piece. So something happens in this middle. So we have an error, and then what happens? We have 0, -1. I'm going to graph maybe the 2 and the -0.5. So about right here, and then about right here, and then I'm at -1 again. So let's see. Oh, I'm going to over one more. -6, -1. Right here. So this one's down at -1. And remember what that looked like. So that one came up, and then came back down, and again, both these sides were hugging the asymptote. Nice little hugs. Okay, then the other part, at 7, we're at 0.75. And then notice that these decrease again and get real close. So this is going to look like this. So there are going to be some problems that ask you to graph. Make sure you put your asymptotes in. Make sure you graph a couple of points. And you can use your calculator to help you. If you don't have your calculator today, you could grab one of my Chromebooks and use Desmos. Sound good? Okay. There's graph paper in the back if you would like to use some of my graph paper. The homework is, and I don't remember what assignment number this is, but yes I do. It's assignment 7. It is page 289 to 290, numbers 21 to 30, no, just kidding, 21 to 24, 31, 41, and 49 to 50.